Hello everyone, and our project title name is GSM based voice data through bone conduction, and our batch members are Mukesh Khanna and myself Joshua Samuel and Balachandra. We are guided by Mr. S. Mukundan ME, Assistant Professor EC Department, Agni College of Technology. And our main objective is to make the inner drum affected user to communicate through GSM modem, and our main objective is to create the intraoral device to regain the lost hearing through a principle named bone conduction principle. An abstract, we are using a GSM modem and with intraoral device allows deaf people to hear through bone conduction, and this is removable, totally invasive and user friendly, and will not affect the user by any mean of things, and it produces non-surgical hearing solutions. And basically on a current scenario, the existing system, several hearing devices available for outer drum problem only, but inner drum problem is usually a permanent condition that can be solved only through a surgery. And as I said, some medical treatment has been proposed, and all that needs a surgery, and this is all the existing system available now. And the problems identified in existing system is surgery causes additional problems like infections, etc., and it is and the cost of the surgery is very high. And our proposed system, and we are here using a GSM modem for network access, and using a PIC controller which interfaces the GSM modem and a vibration strip. And here the main thing the user is AT command, which is known as attention command, which is used to pick the call automatically as the user doesn't know that he may get the call at any time. So we are using the AT command, so it picks up the call automatically. And finally the pick is connected with the vibration strip, which is placed at the user teeth. And as I said, through this bone conduction, the sound from the pick controller is created as a vibration, and through the teeth it travels to the bone, and it directly reaches the cochlea, which will make the inner drum deaf peoples to hear. And this is our block diagram of our system, and we having a PIC controller and a voice playback module and a GSM interfaced with the PIC controller, and we are using a relay for switching between the GSM modem and the voice playback module. And finally we are connected with the vibration strip, and the vibration strip gives the vibration through the teeth, and which will directly reaches the cochlea. And the hardware we are using is PIC controller and condenser mic for us to speak, and a power unit, and a GSM modem for network, and voice playback module for recording and playing voices, and a relay for switching, and audio amplifier to amplify the audio. And software used is MPLAB IDE and embedded C for faster recognition, and PIC-Kit 3. And the advantages here in our project is soundband hearing system will make the inner drum deafness to wear a intraoral device, so they can regain their hearing, and it will avoid the need of surgery, and it will be removable, and it cannot be visible to other people that they are using this vibration strip. So this is our advantages of our project. And finally this is our setup, and using the GSM modem, which has in 12 volt DC input, 3G by 2G network can be accessed, and PIC controller, 40 pin PIC controller, and a voice playback module which can be used 3 pin, 1 to record to play and 3 delete, and relay which use switch between voice playback and call GSM. And finally the strip that I said is vibration strip. It's a eccentric rotating mass vibration motor, creates a force that translates into vibrations. Teeth hearing aid. And finally this is our references. Thank you. And I will now show you the working of our setup. And this is our kit, and the power supply is given here. and this is the GSM modem, and this one is the PIC controller, and this one is the voice playback module, and this is the relay we are used here. And GSM modem, we are seeing two LEDs, and the first LED is the power unit of the GSM, and second LED is searching for the network. And this is the GSM modem, and the GSM modem is used for the network access. And now the call comes to the GSM modem, and we have the display unit here. When the user makes a call to the GSM modem, unit, it will picks up the call automatically. So we'll have the user to see it through the display unit. And here now the call connects via the GSM modem, and both the PIC and GSM modem is interfaced with the serial communication UART. So the information from GSM modem and the PIC controller will be a serial communication. And in this PIC controller, we already have an inbuilt ADC, analog to digital conversion. So the incoming voice signal will be of analog, so it will be converted to the digital by the ADC, and it will be reached to the audio amplifier, which will amplifies the audio. And this is the voice playback module, and here we can record or record anything, music or anything up to 30 seconds, and up to 30 seconds we can hear it through a vibration strip. And here the connected is the mic through which we can speak at the other end. And this relay is the 2-channel relay, which is used to switch between the voice playback modem and the GSM modem. And the final thing is the vibration strip that we uses here. This is the small eccentric vibration motor, which we'll use it in the user's teeth. And as I said, this will work on the based on bone conduction principle. So when the user is fitted with this vibration motor, the sound from the PIC, which is actually a vibration, will travel through the bone, and it directly reaches the cochlea, so that inner drum victims can hear and communicate to one another. And this is the overall setup of a project. And future enhancement can be done in wireless, and this vibration motor can be changed into a vibration strip, so that it may be invasive and totally unremovable. Thank you.